Hello, this is Lindsay Rutner, Junior Research Scientist from IDX20. Today I'm here to show you how to use our Rapid Antigen Test ImageJ plugin analysis tool. We'll go through uploading and adjusting the image in ImageJ, setting the measurements for data collection, initiating the multi-selection plugin tool, inputting the data information, selecting initial corridors, continuing the data collection, and inputting those captures concentration values, and then overviewing the resulting files. So from there, I'll jump right into the ImageJ tutorial. As you can see, I have ImageJ open here, and I'll open one of these pictures I have prepared. And I'll do that just by dragging the image into the ImageJ window. So here it pops up. And this is a routine image that we use for analysis. This is the serial dilution using inactivated virus in COVID cassettes. So to begin this analysis, I need to make sure the image is oriented correctly. So that is done by pressing Image, Transform, and I wanted to flip it 90 degrees to the left so that the cassettes are oriented vertically. Additionally, we like to place our cassettes on a template sheet with red, green, and blue squares in the background, and that's used for color corrections. If you take the image with different phone cameras, this is an avenue for correcting those differences between phones. Once we have the image up, we need to set the measurement to measure mean gray value, min and max gray value, standard deviation, and area. So once those are selected, we can open the plugin. So we do that by going in this top window, you press plugin, and you open the multiple selection tool. Once this window opens, you can see there's a lot of areas for inputting information about the data we'll be collecting. So I'll start by including my name, test series. This input is used for suggestion for naming the files that result from this collection. So I like to include the same name as the image that we're analyzing. So I'll input COVID, that's IV for inactivated virus, trial 1, phone 1. And you can also include a description of the data. So for these purposes, I'll just include demo, test make. This is where you can include the manufacturer of the cassettes that you're using, as this is ultimately designed for comparison between test makes. So I'll include COVID here. Then you can include the max concentration of the stock sample that you're using. So in this case, since I was using virus, it was at a titer initially of 3 × 10⁵ PFU per mil. So I'll include that number directly in PFU per mil, and you can include the volume per test. So I included 100 microliters of samples for each cassette. And once you have all of this information filled out, you're ready to start making collections. So I like to go into the picture and zoom in. I do that by pressing the plus button. Once you're zoomed into the first cassette, and you have your rectangular selection tool, you make a rectangle encompassing the control band and the test band. You select Add Capture. An additional window pops up where you can specify the areas of the control area, white area, and test area. So for that, I zoom in much closer to the image to get on a pixel level. And again, I have my rectangular image selection tool. I get a very specific area of the band and hit control area. Then I'll take a rectangular selection for the white area. And then again, I'll target this dark area for the test area. You may be wondering why this rectangle is so small compared to the rest of the cassette, and that's because this size of the rectangle is used as a reference for the auto capture settings to optimize that selection for the consecutive cassettes. So once I've selected each band, I press OK. And as you can see, the measurements of area, mean, standard deviation, min, and max come up for each control area, white area, and test area, designated in pink, white, and blue. Once these values are inputted, it automatically calculates the signal intensity from the white area intensity mean minus the test area intensity mean, and that gives you the signal intensity. Once these initial measurements are taken, all you have to do is create another rectangle of about the same size from the initial one and press Add Capture. And as you can see, it automatically recognizes the areas that we'd like to select. I'll do a few more for you. So I make the rectangle and Add Capture. Let's say you weren't quite happy with one of these selections. I'll go back to C2 since we have the editing option. I can edit this capture. I press OK. And from here, I can double click on this and simply bring it up or make it smaller. And I'll press Retake Capture. I can reset the capture areas. And I have the chance to create completely new test areas. From here, you can go back and include concentration values, and you have three options to include concentration values. It's through dilution factor, concentration directly, or mass per test. So since I labeled these by dilution factor, I'll choose dilution factor and start inputting those values. The first one was done at a dilution factor of the original stock of 1 to 10. So I'll just include 10, and it automatically calculates the concentration in mass per test according to the max concentration stock. So I'll just continue plugging those values in. And there you have it. This is the complete table. As you continue to make your collections, the table will grow. From here, you have three options to export this data. You could plot signal to concentration, and you can do this at any time throughout the analysis. And this is helpful because it gives you an idea of the signal as you're processing it, so you can always go back and edit it. You can also save an image with all the corridors from the analysis annotated and save all the results within an Excel table. Now I'll show you some already prepared results. This is an exported image from a protein curve. As you can see, all the bands are there. This is the plot for that analysis. And you could save the results, which gives you an Excel file. This is the initial data table, and all the information from the plugin about the data that you're collecting is available at the top, along with the data table that we saw growing as you take data collections in the plugin. The second sheet shows you each specific measure, area, mean, standard deviation, min and max values separately by capture ID and each control, white, and test measurement. And then the third sheet is the concentration versus the signal intensity, the data that we input directly into the R program for further analysis. So that concludes our tutorial. So with this faster analysis and a comparison of the intensity data from different settings, we find it might be useful for streamlined validation of these devices, since the analytical comparisons can be made with much more ease. So with that, I'd like to conclude this video. Thank you for watching, and I hope it was helpful.